Hello guys, let's look at the Fibonacci question in front of us. We've got 5 square tiles, and which ones are those? That is 1, that is 2, that's 3, that's 4, that's the 5th one. And they are put side by side. A quarter circle is drawn. Again, you can see there is a quarter circle here. Okay, that's one of them. Another quarter of circle is here, another one of that, and a quarter of circle here as well. That's another one. So that's number 1, that's number 2, that's number 3. Let's say another quarter of a circle, that's number 4. Another quarter of a circle, that's the 5th one. Okay, and what else are we told? They are drawn on each tile, quarter of a circle drawn on each tile to make continuous curve as shown. Right, that's what they mean by continuous curve. That's a curve, and it continues. There is no breaking on that line. Each of the smallest square has side length 1. So if we put that on the diagram, so that's the length of 1, that's the length of 1, that's the length of 1. Okay, you can see this one will have a length of 2, right? Okay, so that means this square, okay, that square has a length of, is a 2 by 2 square. Okay, this is a 2 by 2. And then you can see that length is going to be 2 plus 1, right? This is 1, this will be 1 as well. And we know up to there is 2, so it's a 3. That means, that implies that this square has its length, side length 3 by 3. And then you can see that side is going to be 5. Here is 3, here is 2, so it's 5. And that means the biggest square is going to be a 5 by 5. Okay. We want to work out the total length of the curve. So the curve forms semicircles in each square. That means it's the outer part, which is the circumference. And this is equal to 2 times pi times radius. Okay. So if we apply that on each square, let's start with square number 1, the smallest squares. Square 1, we're going to do, it's not going to be the full circle, right? This 2 pi r is for a full circle with radius r. So the square 1, which is that's number square 1, is a quarter of a full circle. So we need to do quarter of 2 pi radius, and the radius of that circle, of that quarter circle, is 1. So what we get, 2 1/4 simplifies like that, which we get pi over 2. Well, a square 2, which is also has the same dimension as square 1, let's call that square 2. So that means the circumference, let's write C, of that is also pi over 2. Okay, pi over 2. Let's do square 3. What I mean by square 3 is the square which has radius of 2, right? This is square 3, right? That's the center of the circle. This is going to be the radius. Okay, so in that case, the square 3 has a circumference of, again, it's a quarter of a circle, we have to take quarter, 2 times pi times r, and the radius in that case is 2. So this is 2 times 2, 4, and then 4 divided by 4 is 1, so you're left with pi. And then square 4, which is this square with radius 3, that's a square 4, right? That's the center of the circle, so the radius is 4. So the circumference is 1/4 times 2 times the radius. Oh, so radius is 3 in that case, so I read it wrong. So radius is 3 there. Again, what do we get? We get 2 times 3 is 6, 6 divided by 4, which we can simplify it as 3/2 pi. And then finally square 5, which is our final square, the biggest square. That one has a radius of 5. So the circumference is going to be 1/4 times 2 times 5. And that's going to give us 10 divided by 4. Or you can simplify 2 and 4. It's just going to be same as 5/2 pi. Now total length is adding all these circumferences. So pi/2 plus pi/2 plus pi. So these are the ones I wrote. And now 3/2 pi. And then plus 5/2 pi. Okay. Now the only one doesn't have the denominator 2 is this one, but we can write that as 2/2. Right? That still is 1 pi. Now adding all of them, which we have 1 here, that makes 2, another 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12/2 pi, which is 6 pi. So the total length of the curve is 6 pi. Hence the answer is option A. Thank you much for watching.